Alright, this is test number 3 review, and I'm looking at problems 24 and 25, finding the least common multiple for a set of numbers. Alright, so number 24, and for finding least common multiple can be done in two ways. The way I recommend is using prime factorization. It's much quicker. The way that it makes the most sense and is easiest to list out is like what I have listed out here to the right. And that is for these four numbers here. For the number 15, we have these multiples listed. And you can literally do this. You can list multiples. 15 times 1, 2, 3, 4, 5, 6, 7, 8. And you have to just go up to where you think you need to go. These are the multiples, or some of the multiples listed for 20. Multiples can go on to infinity. These are some multiples listed for 30. These are some multiples listed for 40. The way we find the least common multiple is we have to find the first common multiple between all of them. Well, obviously times 1 for each one of these would not be a common multiple. So then you go to 2. 15 times 2. Well, and looking at the highest number, we can make this faster. 40 times 1 is 40. Who has a common multiple of 40? 30 does not. 20 does. 15 does not. So 20 and 40 are the only ones with a common multiple of 40. 40 times 2 is 80. Who has a common multiple with 40 of 80? 30 does not have that common multiple. 20 does have that common multiple. And 15 does not. So let's go to 40 times 3, 120. 120 does 30 times 4 has a 120. 20 has this common multiple at 20 times 7. Whoops, 20 times 6. And 15 has that at 15 times 8. You finally have 120. So 120 is the least common multiple for these four numbers. But if you have to list multiples for up to maybe 10 for each number or 5 for each number, that's still a lot of work. What a better approach is doing prime factorization and then what is called using canonical notation, which sounds intimidating, but it really isn't that difficult. It's merely looking at exponents and deciding what order to do things. Alright, so let's do a prime factorization of each of these numbers. Number 15 is easy. Prime factorization of number 15 is 5 times 3. Two prime numbers, when multiplied, equal the number 15. Prime factorization of 20 is a little trickier. I have found there's a shortcut for everything. And instead of making trees and cakes and all of that, when you have these easier numbers to work with, you take two multiples that you know, 5 times 4, let's say, and you say, okay, 5 is prime, I'll keep that one. I know 5 still works, and I'm going to multiply it by, I'm going to break that apart into 2 times 2. And so now you have the prime factorization of 20. 5 times 2 times 2, because you have all prime numbers left. And to save space and to be able to do this process correctly, we're going to go 5 times 2 squared. We should write all of our duplicating numbers into an exponent. So for number 30, the cheater's way is to say 3. I know 3 times 10 is 30. 3 is prime. I want to keep that factor. 10 can be broken apart into 2 times 5. So now I have the prime factorization of 30. 3 times 2 times 5. There is no other exponent format to write that in. And 40, let's do the prime factorization of 40, which we know is 4 times 10. Goodness, there is no prime factorization. I mean, there's no prime numbers there, so we have to break them both apart. So let's take the 4 and make it 2 times 2. and then times, let's take the 10 and break it to 2 times 5 as usual. Now we have a prime factorization of 40. And if you multiply that back, 2 times 2 times 2 is 8, times 5 is 40. So that one you can put into an exponent format of 2/3 times 5. Okay, so here's your tricky, or the part that has the trick where you find a least common multiple, because so far finding prime factorizations that's old hat, right? Anyway, so now given these prime factorizations, how do we tell what is the least common multiple? What you do, this is a clever trick, without writing into complete canonical notation, we can do it this way. When you're looking for the highest exponent of each example, what that means is you have a base of 2, a base of 3, and a base of 5. Each one has at least 2, 3, or 5. They don't. This one has 5 and 2, this one has 5 and 3. This has all 3, this has 2 and 5. Doesn't matter. You pull out 5, you look at all the 5s, and you see the exponent is 1. So you say 5. You just pull out the 5 and say, okay, I'll take the 5. 3, there's 3 here, 3, both of those have an exponent of 1, which means they don't have an exponent. So that's just 3. 2, however, has 2, a 2 squared, and a 2 cubed. So we're going to take the largest exponent, and that's all we're going to use. We're going to ignore these two. So now we know if we multiply this, which is 15 times 8, which equals 120, that 120 is our least common multiple of these 4 numbers. And I'm going to do this again. I'll be doing it 4 times. So we found the prime factorization of each number, each one of these numbers, and then we pulled out the highest exponent example from each base. We have a base of 5 represented, but we have no exponents on the 5, so we just leave it alone. We have 3 represented. It's not here or here, but that's okay. We still have to pull it out. And then we have a 2, but we have to pull the 2 with the highest exponent, and that's the one we use for our calculation. Okay, you can list multiples this way, or you can just do the prime factorization. Let's look at 25. We have hardly any room left. But if we take 56 and find the prime factorization, which is, we know 8 times 7 is 56. We know 7 is prime, so we're going to keep that one. And I'm going to change 8 because I know that 8 is 2 cubed. 2 times 2 times 2 equals 8. So I found the prime factorization of 56. 48, we will take 2 factors that we know. 6 times 8 is 48. Well, these are not prime numbers, so we break apart 6 into 3 times 2. And then we take the 8 and we put it to our 2 cubed. However, we have to add one more 2 into that, so it's 2 to the 4th times 3 is the prime factorization of 48. So our prime factorization is there for 48, and our prime factorization looks like that for 56. Of course, that's a little messed up. 2 cubed times 7. Now we have a base of 7. We take that out, and it's represented. We take the 3. And we use a 2, but we don't use the 2 to the 3rd, but we use the one with the higher exponent. And then we multiply to find out what our least common multiple is, which will be 21 times 16, which will be 21 times 16, which is 6, 12, 1, 2. 336. Our least common multiple then of number 25 is 336. That would not be any fun to try to figure out using this method. It's really better to use prime factorization.